Okay, folks, we're going to go over some problems from section 4.2. I know we did a lot of these in class yesterday in third and fifth period, but if you were in first period, I don't think we did a whole lot of them. And then if you were in third or fifth and maybe I went too fast, you could watch this again or scan to the problem that you need help with still, or the one I didn't make sense with yesterday. I'll come over and I'll try a different way if you want. Just give me a little signal in class and I'll come over and help you out. So anyways, one of the, this is called integrated math. So using some algebra with this geometry is kind of important. And we're doing Pythagorean theorem, right? So there's a leg, and then there's a leg, and then there's the hypotenuse. Okay, so this side across from the right angle is the hypotenuse. And the Pythagorean theorem works like this: a squared plus b squared equals c squared. So I'm going to take the 8. I'm going to put it in right here for the a. So let me give myself as much space as possible. So 8 squared, okay, so that's my a squared, plus the b is this crazy expression x minus 4, okay? And the c is the x, so I just have x squared. Hey, let's stop for just a moment. Is x bigger than x minus 4? Well, yeah, because we're taking 4 away from a number, and then we had the original number. So the original number over here, the original number minus 4, this side's going to be smaller than the original number, x, right? Now, let's see, 64, that one is pretty easy. 8 times 8, right? That's what 8 squared means. 8 times 8, okay? Don't mean to insult your intelligence, but I just want to, sometimes people think, well, shoot, man, what does that mean again? Or it looks complicated, but it's as simple as 8 times 8, right? And then x minus 4 squared is the same thing. Let me give myself, again, a lot of space here. Okay, so I'm going to do x minus 4 times x minus 4. That's what x minus 4 squared is. And it's the distributive property. Okay, so like, let's say this was not here. Okay, let's say the x minus wasn't there, but it was just a 4. You would have to take the 4 times x and the 4 times negative 4. After you have done that, then you'd look for like terms, right? But there wouldn't be any like terms. So you'd be done if you distribute the 4. Now, it's not just a 4 sitting here. There's also an x sitting right over here. So let me undo my little scratch work. There's also an x. So like if the negative 4 wasn't here and it was just an x, you'd have to take the x times x and the x times negative 4. It's the distributive property, right? Now, some people may have learned something called FOIL. And FOIL is a way to remember to distribute this term times both of these guys and this term over here times both of these. So let me show you what that means. First, so I'm going to take the first term here times both these guys. Well, excuse me, the first times the first over here. And then I'm going to do the outside. So the outsides multiply together. That's what the O stands for. So the F stands for the firsts. The O stands for the outsides. The I stands for the inside. So here's the insides. And then the L stands for the last. So I'm going to take negative 1 times negative 4. Now, I don't know. I mean, you could just think about it as the distributive property. So we got to take, well, that wasn't a negative 1, it was a negative 4. So I got to go like this. I got to go x times x, and I get x squared. Let me just write my answer right up here. So I get x squared, okay? Then I got to go x times negative 4. And I'm going to put that in 2 different places. I'm going to put it right here, negative 4x, right? This is the part that people forget, is that there's a middle term. So when I go x times negative 4, I get negative 4x. When I go negative 4 times x, I get negative 4x again. So I get 2 of these guys, right? I get 2 of them. So that gives me a negative 8x. So right here, my middle term is negative 8x. Now, what I like to show people is a little shortcut. Do you see how like I could multiply these 2 together, negative 4x, and double it, and that would give me the middle term. The reason why that happens is there's 2 negative 4x's. So you can always do that with a binomial. Binomial means 2 terms squared. The last one I'm going to do is negative 4 times negative 4. So that gives me a positive 16. Okay. Now, what we did in class is we started doing some algebra like subtract x squared from both sides. And we also added 8x to both sides. So I'm going to put a plus 8x over here. So on the right side, now I've got 8x. And then on the left side, I should add the like terms. So where are my like terms? I got 64 and 16. That makes a total of 80, right? So what am I going to do next? I'm going to divide both sides by 8, because that will make me have 1x on the right side. And then I got 10 on the left side. So that's how you do a problem like 7. Now, this kind of problem shows up, I think, 3 or 4 times in our homework. So when we look at a problem like number 3, here it is again. You got to set up your Pythagorean theorem correctly. So x squared plus the square root of 2 squared equals x plus 1 squared. Now let me do a couple things for you and you finish the problem off. So we're definitely going to have an x squared because x squared, right? That's going to show up there. 1 squared is going to be over here. Notice I'm leaving a big gap in the middle for my middle term. To do the shortcut for the middle term, I multiply those two together. I get 1x, then I double it. And that's based on what we saw right back here on this page where, remember how I had two negative 4x's because when I multiply the outside and the inside together, I get negative 4x twice. So that's what I'm doing here, but I'm not just showing, I'm not showing all my work. It's a little shortcut. Square root of 2 squared is just plain 2 because the square root and the squared kind of undo each other. Do all the rest of the algebra on number 3, okay? On number 2, we also talked about number 2 in class. And what I was trying to point out is 3, 4, 5 is a poster on the wall. 3, 4, 5 is a poster up on the wall. It's above the ViewSonic next to the window, to the left of the window. And it's a like white poster that I just made by printing out the numbers on some paper and sticking it together and laminating it. So it's not a fancy poster. If you're looking for a fancy poster, it's not. You're going to get confused. Like, what poster is he talking about? Okay, it's just a little piece of paper on the wall. That means the 3, 4, 5 is the three sides of a right triangle. See how 25 equals 25? I did the Pythagorean theorem over here. So that means we have a right triangle, okay? And the nice part about Pythagorean triples is they're whole numbers, okay? So I was pointing out that we could double each one of those numbers and just come up with a bigger triangle that's similar to a 3, 4, 5. So it's still a right triangle, 6, 8, 10. Or I can multiply it by 5 and get 15, 20, 25. Or I could do something crazy like divide by 9. If I divide by 9, I would get 3 ninths, 4 ninths, and 5 ninths. So 3 ninths is the side length right over here. I know you might say, wait a minute, Nelson, I'm not showing any work. That's the whole idea of Pythagorean triples. No work needed. No work needed. I know some of you guys love that idea because you don't really like showing work. Yeah, so when you have a Pythagorean triple, it's already done for you. The work is already done because I've made the poster for you, and those posters mean that we have a right triangle. All right, hope I made that clear. That one's a little tricky because it's like so simple. You're like, what? No work. Anyways, on this problem right here, you notice it says persevere. You had to do, let's count them up. The first thing I did, let me see if I can find a crazy color I haven't used. Ooh, this magenta or purple, whatever that color is. So I looked in here, I said, man, I want X, but I only have one side of my right triangle. Could I get another side of this triangle over here, like maybe this part here? And I'm like, well, I don't know. I'd like to get maybe the whole side, and maybe I could get this piece, and I don't know. I'm going to work my way to this side over here so I can get closer to having this piece. So then I noticed, well, I got two sides right here. Well, maybe I could find this side right here. So look at the 7.5 and the 11.6. This was my first step right here. That's maybe not going to show up super great. So step number 1 was do the Pythagorean theorem here. And we ended up with, well, we did it on the calculator. We did it on Desmos to make it as accurate as possible. So I don't have my answers over here, okay? You got to do it on Desmos. Then after we got this piece right here, it came out, I don't know, where is it? Maybe it's clear, oh boy, where is it? Yeah, it came out to be about 8.8. So this side right here is about 8.8. I'll just write it again. All right, that's after we did the Pythagorean theorem. Then we did the Pythagorean theorem down here to find this side over here. So E came out to be 17.4. All right, so this was Pythagorean theorem number 2 right there. And then let's see, after we did that, we did Pythagorean theorem on this triangle. So we did 2.7 and 13. So here is Pythagorean theorem number 3. That's weird how stuff just shows up. Some reason it's covered up right now. And then after we got this side was 12.7. Okay, 12.7 right here. We subtracted 12.7 from 17.4, and we got something like 4.7. So this part right here is 4.7. Now remember, these are all rounded numbers. Okay, this is 4.7 right here. All right. So then we did Pythagorean theorem again with 4.7 and 2.7. Now, do I have that work anywhere? Oh, I do right here. This was the fourth Pythagorean theorem that we did right up here. So if you try it on Desmos, it's got to be rounded to the nearest 10,000th because they're making you keep all that decimal stuff on Desmos. 10,000ths place. Let's think about that for a second. Here's the tenths place. Here's the hundredths place. Here's the thousandths place. Here's the 10,000ths place. You need 1, 2, 3, 4 decimals. 4 decimals. Okay. So hopefully you can keep all that on Desmos and get number 6 right. I think that's number 6, isn't it? All right. Number 7's another one of those. Well, we already did number 7, right? That was the first thing I did. So I'm not going to go over that. Let's see. Is there one that we went over down here? Oh, yeah. I wanted to show you this. Here's another Pythagorean triple that we could practice. Notice 3 will go into both these guys. So 3, if I divide that guy by 3, oh, geez, I thought I had my pen still turned on. If I divide that by 3, that's not going to work. Let me undo that. Hold on one sec here. Okay. So 24, what's going on there? That's so weird. 24 divided by 3, I'll just write it. Hopefully you guys can see that. 45 divided by 3, that gives me 15 for that side, and it gives me 8 for that side right there. I have a poster on the wall that says 8, 15, 17. Now they're all divided by 3 to get down to 8, 15, 17. So we got to multiply by 3 to get back to my original side length. So this one's the 24. This one's the 45. And then 3 times 17, I'll just write 3 times 17 right here. That's 51. So this side right here is 51. That's how you use Pythagorean triples to find unknown side lengths. Number 9, find the value of x. Now, can I use Pythagorean triples here? Let's see here. That's 3. This side is 5. If I divide them both by 3, okay. Now, that's the same thing I divided up here by 3. Do we always divide by 3? No, I'm just seeing what is a factor that can divide into both these guys. So this side would be the 4 side, but that would be a triangle 3, 4, 5. It's on the poster over there. But it's 3 times smaller than my actual triangle that I got right here. So 4 times 3 would give me 12. Okay. Do you see how I'm doing a lot of thinking in my head, but I'm not putting any work down. Pythagorean triples require no work at all. Okay. Over here, do we have any Pythagorean triples? Let's see. Can I divide 16 and 33 by the same number? I don't think so. So this is not a Pythagorean triple. You have to go straight away to Pythagorean theorem. 33 squared is equal to x squared. Do that on Desmos, round to the nearest tenths place. Oh, they say this one's a Pythagorean triple. It's not a poster on the wall. So when I divide, let's see, 4 goes into here 3 times. 4 goes into there 5. It's another 3, 4, 5 triangle. So this must be the 4 side right over here. But I divided by 4 to get down to the 3. So I got to multiply by 4 to get to x. So x must be 16. Okay. Is this a Pythagorean triple? 11 and 28. Let me look at the wall there. Do I see 11 and 28 anywhere? No, I see 11 and 60, 61. No. So I'm feeling like it's not a Pythagorean triple, and I can't reduce it down. So I'm going to go 11 squared plus x squared equals 28 squared, and then just go ahead and do all the Pythagorean theorem on that guy. Okay. Let's see. What else do we got? 15 is another one of those where you got to do a little algebra. Let me zoom out. Is there another one that we should go over here? I don't know if there's a Pythagorean triple. See if you got 14 right. 15. Can I divide those by 5? Or 16. This is number 16. 5 goes into there 5 times, right? And 5 goes into here 13 times. Oh, yeah, it's a 5, 12, 13 triangle, but it's just 5 times smaller if it's in purple than it is in black. So in black, I got to multiply this by 5, and that gives me 60 for the x side. Hey, I hope me going over these homework problems in video form is helpful to you. If it's not, call me over. I'll help you out.